Today we're talking about comparing slopes. So we're going to start off by finding the slope of this graph and finding the slope of this graph. Remember, slope is positive or negative, rise over run. Before I can do that on our graph, I need to find two perfect points. So I've got a perfect point here. I have a perfect point here. Remember, perfect points go over a crisscross. Perfect point here and a perfect point here. I can pick any 2 points because the slope between this point and this point is the same as the slope between this point and this point, which is the same as the slope between those 2 points, and it's the same as the slope between those 2 points. Draw a right triangle between any 2 of these perfect points. I'm going to use this point and this point. Draw a right triangle. The rise is 1, 2. Oh, sorry, I'm looking at the run apparently. 1, 2, 3, 4. So the run is 4. The rise is 1, 2, 3, 4, 5, 6. So the slope is positive or negative 6 over 4. I'm reading from left to right. That goes up, so this is positive. So the slope is positive 6 over 4. These are both divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 3 halves is simplified all the way. So my slope is positive 3 halves. The slope in this graph finds 2 perfect points. There's some perfect points. If I use the 2 end perfect points, would I get the same slope as if I used the 2 middle perfect points? The answer is yes, because all of these points are on the same exact line. So let's go ahead, and I'll use a smaller triangle because there's less counting involved. We need positive or negative, rise over run. The rise is 1, 2. The run is 1, 2, 3. Going from left to right, this line goes up, so the slope is positive. I want to compare which one of these is steeper. Which one of these is steeper? So I'm comparing this line, and I'm comparing this line. The green highlighter is going up way quicker than the blue highlighter is going up, which means the green one is steeper. The green one will be on this line. So the graph on the left was steeper, which means which line is flatter? The one on the right. Okay, what was the value of the slope for the steeper line? So the steeper line had a value of 3 halves. We don't use decimals with slope, but when I'm comparing them, it's not such a bad idea because we're really good at comparing decimals. 3 halves is the same as 1.5. You find out by taking 3 and dividing it by 2. 2 thirds is the same as 2 divided by 3, which is 0.6 repeating. What do you notice about 3 halves and 2 thirds? Which one of those is bigger? 1.5 is bigger. So the slope of the steeper line is bigger than the slope of the flatter line. 3 halves is larger than 2 thirds. So the steeper line has a bigger slope. What do you notice about the value for the flatter line? Well, the flatter line has a slope of 2 thirds. When we compare 2 thirds and 3 halves, 2 thirds is 0.6, 3/2 is 1.5. 2/3 is less than 1.5. So that's this comparison symbol, which means the flatter line has a smaller slope. Okay. And that's true for everything. Slopes with a larger absolute value are bigger, steeper. I included absolute value because sometimes you might have negative lines, and a negative line like this compared to a negative line, or a positive line like this, the negative line is still happening way faster than this positive line here. So when we're comparing slopes, we only want to compare the actual number part, not the sign. We'll write that down up here. Compare, that's called the absolute value. Absolute values. That means we are not caring about the sign, not using the sign. We still include the sign with our answers. When we're comparing them, we're going to ignore the sign for a moment while we compare them. Slopes with a smaller absolute value, or smaller absolute values, are flatter. Okay. You can go ahead and pause this video, find the slope of all 4 of these lines. I'm going to label these lines A, B, C, and D. So go ahead and pause this video and find the slope of all of these lines, please. Okay, so now that you've paused the video and taken some time, I have found the slope of each of these lines. The slope of the first line was 1/3. The slope of the second line was 1/2. The slope of the third line was 1. And the slope of the fourth line was 2. And these were all positive going from left to right. All of these went up. Okay. We want to put these in order from steepest to flattest. So the biggest value of the slope to the smallest value of the slope. So I've also written the decimal values just so I can compare them easier. Please remember that with slope, you write them as fractions. When we're comparing slopes, though, we want to see the decimals, so it's easier to compare. The biggest number between 0.3 repeating, 0.5, 1, and 2 is 2. So the steepest line is D. Now I'm comparing 0.3, 0.5, and 1. The steepest line there is C because 1 is bigger than those two numbers. I'm comparing 0.3 repeating and 0.5. If I had 33 cents or 50 cents, which one is more money? B with 50 cents. So the next steepest line is B with a slope of 1/2. And then that leaves A as my flattest line. This is in order from steepest to flattest. Take another moment, pause this video, and find the slopes. For example, 2, find the slopes of these lines. Pause this video and find the slopes of those lines. Okay, I accidentally paused the video, or I tried to pause it, but I stopped it. Anyways, here are the new slopes, or here are the slopes from the lines I asked you to find after pausing the video. This question is asking us to put them in order from flattest to steepest, so that is small to big. And remember, we're only looking at the positive values here, or the absolute values, I'm so sorry. So this is 4. I'm going to ignore the negative sign for now. That's 1. So I'm comparing 4, 1, 0.75, and -3. I'm going to ignore the negative for a moment. Compare 3. I want flattest to steepest, so I need the smallest number here, which is 0.75. So C has the flattest slope. Now I'm comparing 4, 1, and 3. 1 is the next smallest. Remember, the slope was -1. I'm using a 1 to compare it. The slope was -1. The -1 is the next flattest slope. Now I'm comparing 3 and 4. 3 is smaller, so -3 is the slope that is next flattest. And then that leaves A as the steepest slope. What do you think this means about undefined slopes? Remember, undefined slopes look like this. Is there any line that is steeper than that? The answer is no. That's why Slope 2 dies when he goes down this, because it's so steep that you just fall straight down. So undefined slopes are the steepest. What about slopes that are equal to 0? Zero slopes. There's nothing flatter than this. It doesn't go up at all. It doesn't go down at all. There's no movement. There's nothing flatter. So this is the flattest type of slope. Okay. This is page 38, 39. This is page 39 on the front. Go ahead and flip over to page 40 on the front, and we'll look at your assignment. Okay. You have two boxes with a whole ton of lines. You need to find the slope for each of these lines. This is line A. Put the slope for line A right next to that. Do the same thing here. This is line R. After you find the slope for line R, write that in the box right next to R. Then you're going to tell me what the steepest line and the flattest line is for each set of these lines. So I want the steepest line out of A through H, and I want the flattest line from A through H. I want the steepest line from L through S, and I want the flattest line from L through S. And that is your assignment on page 40. Yeah, page 40 on the front. If you have questions, feel free to message me on Schoology or drop a comment below, and I will be glad to answer as soon as I can.